Let's take a look at the true and false questions for chapter 3, as well as some practice problems. We start off with the first one. The median of a data set is found by adding all the values in the data set and then dividing the results by the number of observations. This is false. All we need to do for the median is place the data in order, and the median will be the value in the middle of the order data set. Outliers are extreme values above or below the mean that require special consideration. Absolutely, this is true. Outliers are values that are extremely high or lower than a typical value in a data set. There can be more than one mode in a data set. That is also true. There can be more than one, or there can be 0 modes. Some data sets may not have a mode. Absolutely, we just mentioned that. This is correct. The standard deviation of a data set can never be negative. 100%, you can never have a negative standard deviation. It measures the distance. You can never have a negative distance. Number 6, using n-1 in the denominator for the sample variance is a match between estimate of the true population variance when compared to dividing by n. This is true. When comparing two samples, the smaller coefficient of variation indicates more consistency or less variability within the sample of population or population. That is also true. The smaller the coefficient of variation, the less variability you have within the data set, the sample or population. Let's look now at the multiple choice questions. The what is the value in the data set for which half the observations are higher and half the observations are lower? This is the definition of the median. The what is found by determining the index point I is equal to 0.5 times n, where n is the number of data points. This is again the median. The median is the 50th percentile. 50% of your data is above and 50% is below that value. The what is the value that appears most often in your data set? This would be the mode. Which one of the following statements is true for a right-skewed distribution? The correct statement would be that the mean is greater than the median. The what can be found by subtracting the lowest value from the highest value in the data set. This would obviously be the range. Maximum minus minimum. A disadvantage of using the range as a measure of variability is that it is highly influenced by outliers. And this is the most important disadvantage of the range, because it's simply the difference between two numbers, and if one of these two numbers is an outlier, this can greatly impact the output of the data set. What is the most common and most important measure of variability in the field of statistics? This would be the standard deviation. We consistently use the standard deviation to compare data set and analyze data sets. The what measures a distribution's standard deviation in terms of its percentage to the mean. This would be the coefficient of variation. The average SAT score for incoming freshmen at a particular college is 535 with a standard deviation of 60. The coefficient of variation for SAT scores at this school is, all we need to do is take the standard deviation and divide it by the average, which is 535. This will give us 0.112 times 100%, and this will give you the coefficient of variation, which in our case is 11.2%, low variability. The what identifies the number of standard deviations a particular value is from the mean of the distribution. This would be the z-score. The z-score will give you the number of standard deviations a value falls from the mean. Let's look at the problems. There are currently 7 statistics classes being taught this semester at Wilmington College. The following data represents the number of students in each class. Calculate the population mean. The population mean, mu, would be equal to what? The summation of all the entries over the total number of entries that we have. So you would do 20 plus 25 plus, we take into account all the entries, and we divide it by the number of entries, by n. N in this case would be equal to 7. And since this is a population, it would be a capital case N. Your population mean would be 25. The following data represents the amount of money that the last 9 customers sent at the checkout of a local Costco, rounded to the dollar. Calculate the median of this sample. To calculate the median, the first thing that we will need to do is place our data in order. So, first step, you place the data in order: 78, 106, 118, 120, 169, 183, 193, 225, and 256. So, to find the median, we would calculate the 50th percentile. I is equal to 50 over 100 times 9, because 9 is the number of entries that we have. N is equal to 9. So, 0.5 times 9, this would be equal to 4.5. We round up to the next convenient number. So, I is equal to 5. That means we take the 5th ranked observation. So the 5th ranked observation would be 169. There are currently 7 statistics classes being taught this semester. The following data represents the number of students in each class. That's the same example as above. Determine the mode for this data set. If you pay attention in your entries, there is not a single mode that repeats more than once. Therefore, you would state that we have no mode. No mode. All data appear once, therefore there is no mode. There are currently 7 statistic classes being taught this semester. Again, the same problem. The following data represents the number of students in each class. In this case, I want you to calculate the variance. How do I calculate the variance? I use the following formula: S squared, this is the symbol for your sample variance, is equal to the sum of all the squared entries minus the sum of all the entries squared over the sample size, and all of this over n minus 1. Now, how many entries do I have? N is equal to 7. N is equal to 7. So the first thing you will do is calculate the sum of all the squared entries, and then you will calculate the sum of all the entries. How do I calculate the sum of all the squared entries? You will take each one of the entries that you have and you will square it. So this will be 20 squared plus 25 squared plus 28 squared. And this will be 4,541. And then you simply add the entries that you have, which means 20 plus 25 plus 28 all the way to 175. They add up to 175. All you have to do next is take these values and plug them in your formula. The sum of all the square entries is this number right here we have just calculated. So 4,541 minus the sum of all the entries, 175 squared. Do not forget to square it, over what is n? 7, and all of that over 7 minus 1, n minus 1. If we do the calculations, this will be 27.667. So your sample variance is 27.667. A soda producer conducts a taste test for 2 different cola formulations. Each individual rates one of the formulations on a scale of 1 to 20. The taste test data is shown below. So you have 2 data sets. You have for cola 1 and you have for cola 2. Which formulation provides the most consistent taste test result? That means when we talk about consistency, it means the lowest variability. To do so, we will need to find the coefficient of variation for each cola and then compare the results. And then we have to compare the results. So, to find the coefficient of variation, we will need the standard deviation and we will need the average. So, let's start with cola 1. The X bar, the sample mean for this data set will be, we add them all, 14 plus 10 plus all the way to 8 over, how many entries do I have? 7 is equal to 11.4. To find the standard deviation, I will need to take the square root of the sum of the square entries minus the sum of entries squared over n, and all of that over n minus 1, which will be 956 minus 80 squared over 7, and all of this over 6. If we do our calculations, the standard deviation for the first data set will be 2.637. I'm rounding up to 3 decimals. So that means the coefficient variation for the first cola will be 2.637 over the average, 11.4 times 100%. So the coefficient of variation is 23.13% for the first cola. So let's do the same for the second cola. X bar for the second set of data, cola 2 right here. We add them all, 18 plus 6 plus 11 divided by 7. 7 is the number of entries we have. This is going to be 12.6. To find the standard deviation, I need to take the square root of the variance. To find the variance, once again, I need to take the sum of the square entries minus the sum of the entries squared over n, and all of that over n minus 1. The sum of all the square entries, I take each one, I square it, and then I add them, is going to be equal to 1,276 minus 88 squared over 7, and all of this over 6. So if we do our calculations, this will be 5.318. 5.318. So the coefficient of variation for the second set of data will be 5.318 over 12.6 times 100%, and this will give us a 42.21%. If you were to compare the two coefficient of variations, you will see that the first group for COLA 1 has a lower coefficient of variation than the second group. That means we have a higher consistency, or in other terms, a smaller variability. Therefore, COLA 1 has a smaller variability. Now, problem number 6. Suppose the employee's share of annual healthcare costs for 2012 is thought to be bell-shaped and symmetrical with a mean of 2,764. So mu is equal to 2,764 and a standard deviation of 426. Based on the information, what interval of annual healthcare costs would be expected approximately 95% of employees fall within? So basically, I'm looking for 95% of the data will fall within how many standard deviations, basically. Since I know that I have a symmetrical distribution, a bell-shaped distribution, I apply the empirical rule. Based on the empirical rule, 95% of the data falls between mu plus minus 2 standard deviations, because it's a 95%. So we have mu is 2,764 plus minus 2 times the standard deviation. So this would give you an interval from 1,912 to 3,616. Always be careful of the percent for the empirical rule. Based on the percentage, the number of standard deviations will also change. Now, Candy Kitchen sells chocolate non-parallels in 8-ounce containers. Because the candy pieces are not uniform, the weight of each individual container varies slightly. A random sample of 9 containers, n is equal to 9, was weighted on a precision scale, and the results are shown below. I want you to determine the interquartile range for this sample. Are there any outliers in this data set? Now, to find the interquartile range, we will need to find Q1 and Q3. So, IQR, let's write it down. Q3 minus Q1. We know that Q1 is equal to P25. To find P25, we need to find the 25th percentile. Before we do so, I have to first place the data in order. So always remember that the first step is an order data set. So we have 7.86, 7.85, 7, 7.99, 8.03, 8.06, 8.08, 8.09, 8.20, and 8.43. So index I will be equal to 25 over 100 times 9. 9 is the number of entries we have. This is a 2.25. It's a decimal. I round up to the next convenient number. That becomes a 3, which means I will have to take the third ranked observation. So Q1 will be equal to 7.99. The third ranked observation. 1, 2, 3. Now, to find Q3, I will have to find P75. Index I is equal to 75 over 100 times 9. This will give me 6.75. I round up to the next convenient number, which is 7, and I take the 7th ranked observation. The 7th ranked observation is 8.09. So IQR is equal to 8.09 minus 7.99, which is equal to 0.1. Now, to see if we have any outliers, we have to find the upper limit and lower limits of the outliers. So the lower limit will be equal to Q1 minus 1.5 IQR, and the upper limit would be Q3 plus 1.5 times IQR. So we just plug in the numbers. We have 8.0 for the lower limit, we have 7.99 minus 1.5 times 0.1, which is 7.84. And for the upper limit, we have 8.09 minus 1.5 times 0.1, which is equal to 8.24. The last observation, if we notice in our data set, is greater. The last observation is greater than the upper limit. So the container that weighs 8.43 ounces is an outlier. So 8.43 can be considered an outlier. The last problem. The following data represents the amount of time in minutes that a random sample of Parisians spent eating lunch in a particular cafe. Determine the 5-number summary and create a box and whisker plot. Now, the 5-number summary consists of minimum, Q1, Q2, Q3, and maximum value. First thing I need to do is place the data in order. So I will have 17, 18, 20, 21, 23, 24, 25, 27, 29, and 39. Now, we have 10 entries. That means that n is equal to 10. What is the minimum entry? The minimum is 17, maximum is 39. How do I find Q1, Q2, and Q3? I need to find the corresponding percentiles. So, for Q1, I will be equal to 25 over 100 times 10. This is 2.5, which I round up to 3, and I take the third ranked observation. The third ranked observation is 20. So Q1 is 20. For Q2, 50 over 100 times 10. This is going to be equal to 5. That means I take the average of 5th and 6th observation. 5th and 6th ranked observation. So Q2 will be equal to 23 plus 24 divided by 2, 23.5. For Q3, 75 over 100 times 10, 7.5. I round up to 8, and I take the 8th ranked observation, which in this case is 27. So I have all the information I need to create a box and whisker plot. I start with the minimum entry. I extend whiskers to Q1, where I start the box. Q1 is 20, 27. For Q3, 23.5. For Q2, and then I extend the whiskers to the maximum entry, which is 39. So something like this for the box and whisker plot. So this concludes the true and false questions and examples and problems for chapter 3.